Okay, so now we're going to turn our attention to the next subsection, which is going to be Laplace's, or the next section, which is Laplace's formula. We're going to start with Laplace's expansion. And to kick it off, we're going to do an example, and we're going to start with a permutation expansion. Okay, so this is the permutation expansion that we talked about before in the last subsection. And this is the expansion, okay? So what we're going to do is from this point here, what we're going to do is look at factoring out a particular row and column, okay? Now, it doesn't really matter which row and column that we use. I'm missing something here. I got it. Okay, so what we want to do is we want to factor out one of the rows. Okay, it doesn't matter which row, like I was saying. So in this case, we could just do the first row. Okay, so we're going to factor out the first row, which would be T11. So we'll factor out T11 from this set, right? T11, and then we'll do what's the first row here? T12 and T13. So we'll just factor out the first row. So that would be this one, and this one. Okay, so let's do that. And I'll just, instead of erasing everything, I'll just do this. Okay, I'm going to bracket that off, and then this one, I'll factor that out, so I'll bracket this off, and then I'm going to factor out this one, and I'll bracket that off. Okay, just so I don't have to erase and rewrite stuff. Oh, and that goes away. Okay, so now once we factor out the first row in each of these groups, now what we're going to do is notice that the first term in each of these, well, okay, before we do that, I want to swap rows. So in those because we did the first row, we want to swap and get the first row in its place. Okay? Meaning we want the first row with the 1 up here. Okay? Now, with the first grouping, we don't have to do anything. It's already in the first position. So, but we're going to have to swap rows here. So in the second grouping here, we'll have to do 1 swap. Okay, so we'll have to swap these two. Right? So it'll involve 1 swap here. So these two, and then we'll swap these two. And these are going to require 2 swaps. Because what we're going to get is we have the identity here, and so we're going to want to get the identity here and the identity here. So if we swap these two, we'll do it. And here it'll require 2 swaps. We'll have to swap these two and then these two. So it'll involve two swaps on the third grouping. Okay, and we're going to do the same thing with both of them. Okay. So let's see what happens here. So again, don't have to do anything here. We've already got this already done. So now if I swap, now, oh, by the way, we have to keep track of our signs. Don't forget to keep track of our signs because remember, swapping rows changes the sign. So if we swap these two, okay, then we'll have to do it over here. Or hold on. Nope. Hold on. That's not what I want to do. I'm getting ahead of myself. I want yeah, I want to switch these two. I want to switch row 1 and row 3. I want to get this up here. So that means this is going to go 1. Like so. Okay. And then of course, because I made a swap that's going to bring a negative sign outside, right? It's going to bring a negative sign. Okay. Now here, I'm going to do the same thing. I want to put the 1 here. I'm going to do 2 swaps because I want to get the diagonal here. So here I'm going to do 2 swaps here. So I'm going to first swap these 2 rows. So this is going to be 0, 1, 0, 1. Okay, so that'll be 1 negative. And now I'm going to switch these 2. So this is going to be 1, 0, 0, 1. And so that'll bring out another negative. And likewise, switch these 2. And then these 2. Okay. Now, again, we took these permutation matrices and we swapped to get the first rows into place. This, again, required doing 1 swap in each of the permutation matrices in the second line and 2 swaps on each on the third line. Okay, so we kept track of the signs, so we got that. And now, look what we have here. Okay. We have the identity matrix on the first one of each grouping, right? The first one on each group is the identity matrix. And over here, we've got the same pattern over here. We've got this in the first row, right? And then we've got these, okay? But also, look what we have here. Instead of the identity, we've got the 1 in all of the first corners. Right, we've got the 1 in its place, but look here, we've got these 2 and these 2, these 2 and these 2, these 2 and these 2, okay? So look what happens if we recombine things. First of all, let's take care of the signs. So these cancel each other out, these cancel each other out, this is negative, so we'll factor out the negative, and we'll make this into negative. Okay? Now, what we're going to do is we're going to take these 2 and multiply them back in the same way when we factored them out, which was row by row. So this 2 by 2, this is the second row, right? So this is going to be multiplied through the second row. So what's that going to do? That's going to put a T 2 right there, and that goes away. Okay, and then we're factoring back. We're going to multiply back in the third T33 to the third row. That's going to put T33 right here. Okay, and then we do the same thing over here. We're going to get T23 and T32 here. And now if we add these determinants, what do we get? We get, well, I'll collapse this one here. So if we add them, then what happens over here? We add them and we get T23, T32. So I'm going to erase this. And we get T11. And if we do the same thing here, look what happens. Same thing's going to happen here. We've got, we'll end up with T21, T33, and we're going to end up with T23, T31, and of course then these go away because we just multiplied them through, right? And then this goes away because we added both of the determinants. And then if we do the same thing here, right, we're going to get T21, T32, and of course we're going to do the same thing over here, but we're going to add them. And so it's going to be T22, T31, and then this reduces to a 2 by 2 determinant because we've got this one here. So this actually will just reduce down to and simplify to this determinant, that determinant, and that determinant. So what we ended up with is this determinant is equal to T11 times this determinant minus T12 times this determinant plus T13 times that determinant. Okay? And what it corresponds to is, notice what happens here. If we take T11, right, and we ignore the row and column that T11 is in, what do we get? We get what's left over. T22, 23, 32, 33. And we have this cofactor, or not cofactor, but we have this block right here that actually turns out to be the determinant of what we want to find for the first term. And then also look at T12. If we take T12 and we ignore the row and column that that's in, look at that. If we ignore this row and this column, look what we have left over. 2, 1, 2, 3, 3, 1, 3, 3. And if we take 1, 3, right, and we take that 1 and we ignore the row and column that that's in, what do we have left over? We have this 2, 1, 2, 2, 3, 1, 3, 2. And so now we've got this process, this algorithm, right, that we can take to apply to 3 by 3 determinants, or determinants for 3 by 3 matrices. Okay, so now we're going somewhere, and see now the previous theorem that we did generalizes this example. Okay. This is kind of cool. So now we've got something we can work with that now takes what we had in the theorem and now applies it. And now once you see it, once you start getting used to applying the theorem, right? Now we've got a easy way to figure out how to expand these out and simplify them. And again, these are the cofactors. That's what we call the cofactors here. So this would be one cofactor, and then so on. Okay? And so I went through that whole process with this example to lead you to the end result, which is this. And now we're going to add a couple of definitions and do some more examples.